Welcome everyone to our weekly space hangout for Thursday, September, what is it, 19th, 20th, 2012. This week, we're going to be talking about the fact that NASA is working on a warp drive. Neil Armstrong buried at sea. Curiosity is going to be examining its first rock. Discovery of the oldest, furthest, youngest galaxy. And there was one more story. Oh, right, an eclipse of Phobos seen from the surface of Mars. So joining me this week for the Weekly Space Hangout is my regular crew. We've got Amy Shira Teitel from Vintage Space. We've got Dr. Ian O'Neill from Discovery Space. We got Jason Major from Universe Today and Lights in the Dark. We've got Nancy Atkinson, editor at Universe Today. And we've got Dr. Nicole Gugliucci, the noisy astronomer from CosmoQuest. So I think what do I want to talk about first? I think I want to talk about the warp drive. Warp drive, warp drive. So, because that was such a cool story. Ian, I don't know if you worked on this story directly, but I know that Discovery posted a really big story on this. So what's the news on this?
Yeah, I was actually at the 100-Year Starship Symposium over the weekend. Of course, that's where all the geeks from around the world descend on Houston, and it was the 100-Year Starship is basically being set up by DARPA. They provided seed funds, and a group of scientists and enthusiasts have got together, and they're just basically trying to make interstellar travel happen in 100 years, hoping to have a plan for, or at least some sort of semblance of a plan to send humans to another star. Now, obviously, with any kind of symposium like this, you're going to get the pretty extreme stuff. I mean, it wasn't all about warp drives. Obviously, that is considered extremely exotic. The more mundane, like fusion drives, obviously that's considered more mundane now. There were other propulsion methods mentioned, but it wasn't just all about that. It was all about the human impacts, food, life support, all this kind of stuff. So. But one of the things, of course, that came up was the warp drive, and it's always vastly popular with the press. And unfortunately, I was actually chairing my own session on called Becoming an Interstellar Civilization, so I wasn't able to see the talk itself, even though it was happening just next door. But of course, the world press went crazy for it, and we syndicated one of the Space.com articles on Discovery News because Space.com sent one of their writers there. And basically, the upshot is, yes, NASA is planning, well, they are actually doing an experiment. I mean, it's a laboratory experiment, so it's on a very tiny scale. But they think they have, they've possibly found a way of replicating a warp of space-time in a laboratory. Now, basically, if you take a few steps back, the whole idea behind the warp drive is, very Star Trek. And it wasn't until 1994 that a scientist called Miguel, I can't pronounce his last name, Alcubierre, I think his last name is, he actually put some equations to the whole warp drive concept. But the upshot of that was, using the technology that he understood in that day, you'd need the equivalent energy of the entire universe to propel this warp-driven spaceship. So obviously it's still in the realms of science fiction. Then along came Richard Debussy of Icarus Interstellar, who I know quite well. He came up with a new formalization of the warp drive in 2009 when he wrote his PhD thesis on manipulating extra dimensions and using dark energy to create a warp bubble around a spacecraft. Now, his calculations suggested that you just need the equivalent energy of the size of Jupiter. So, still huge, but ultimately it can be used. And then in this conference, what was really newsworthy, Sonny White from NASA's Johnson Space Flight Center came forward and said, with a few design tweaks of this of the spaceship, perhaps it can use the equivalent energy of the Voyager probe. So, so he did the talk, obviously, and everything was cool. But really, the key thing was he came out with this wonderful, understated line saying, "Oh yeah, we're going to test this." And so obviously the warp press went a bit crazy for it. And basically what he's saying is he's going to use he's got a setup at Johnston, and it's called the White Jude Warp Field Interferometer. And it basically uses a laser interferometer to create microscopic warps in space-time. I wasn't there at the talk, and I'm trying to get hold of the video from the talk, so I'd love to see what that actually entails. But that's really the cool thing. They are actually creating a scale model of a warp in space-time in the lab. So that's really the big news. So I don't know whether it's possible. I mean, still the energy of the rest mass energy of the Voyager probe is still pretty big. I think that equates to like a couple of hydrogen bombs, but at least it's not the scale of the universe or the scale of Jupiter. So I think that's really the upshot from this.
Right. Oh, I was going to ask a couple of questions, but I wanted to remind everyone that that you can ask us questions if you're watching this live. If you're watching this on Google Plus, go ahead and just post a comment into the Google Plus comments. If you're watching this on YouTube, we can see the questions there. If you're watching this on the event itself, we can see it there. And if you're watching this embedded somewhere out on the web, you can just post your question, like on Twitter, for example, and with the hashtag Space Hangout, and we will be able to see it there. So. And we'll try and get to the questions either sort of during the segment or maybe at the end if they're more general questions. So, so Ian, I guess I kind of feel like there's no way this is true. Do you know what I mean? I mean,
yeah.
I feel really kind of just, I don't know, numb, like science fiction. In some cases, science fiction is totally delivering. We've got iPads, we've got jetpacks and flying cars. No, wait a minute. But the warp drive, I mean, that's it. That's the big thing. If you get a warp drive, suddenly you're zipping across the universe. You're meeting aliens. You are battling on desert planets with lizard creatures. I mean, that's it. Science fiction will have arrived. So I mean, can you please put this in context for people on how much they should base their future on this?
Well, that's the thing. I mean, obviously, with any science fiction notion, of course, the warp drive was mainly invented so you could have episodes of Captain Kirk going from star system to star system. The interstellar space didn't matter then. I mean, you didn't have whole seasons that went on for centuries rather than weeks. So it
with
was
terrible time dilation. I actually just read Forever War, right, where the main character in Forever War, by the time he's done his 4-year mission, 1,000 years have passed back on Earth, and the war has been long forgotten.
Yeah, exactly. Yeah, so you've got all these these hypothetical questions that come out of this, but it's just one of those the human mind can't wrap itself around the vast interstellar distances. And that's really what the whole 100-year starship thing was set up for. I mean, whether or not they actually come on a plan to actually send humans to another star is neither here nor there. But the big question is, how could we even conceive to do this, sending humans across light years? I mean, the Icarus Interstellar are actually working on a robotic probe, which I see as more immediate. I mean, at the end of the day, the Voyager probes are becoming interstellar probes, so it's not as if we haven't done this. It just takes a long, long, long time to send anything over the interstellar space. So, so really, the idea of the warp drive is extreme physics, and it comes with a caveat of if we have sufficiently advanced technology in the future. But if you look back at 100 years ago, we're just going into powered flight. I mean, space travel was pure science fiction. I mean, even if it was considered. Now we're looking at interstellar flight as if it's science fiction. But actually, we do have some ideas to how that could be achieved. So the warp drive would be useful. It's not necessarily going to happen, but the key thing is NASA's actually seriously putting funding into this, and they're actually testing this laser interferometer to see if they can actually create these little warps in space-time. Now, whether that can be harnessed and controlled, and you'll see that other scientists, they will always refer to exotic energy to manipulate space-time to create this warp bubble so it can carry space-time with the spaceship. So you can basically travel at infinite speed. You can, the speed of light suddenly isn't a limit for the warp drive. And I think I think Sonny in his meeting said that he can travel, by his calculations, the warp bubble could travel 10 times the speed of light. So the nearest star system was four light years away. That significantly cuts down the transit time to weeks to months rather than thousands of years that is going to happen at the moment if we just went under conventional propulsion methods. So the upshot is, yes, it's science fiction. Yes, we have to assume a lot of technological advancements in the near future. But ultimately, the calculations are saying it's just design requirements on the warp ship, and also we have to assume some kind of exotic energy to create this warp bubble. But the equations are there. This is real physics they're using. It's just our understanding of physics right now that we're using. 10 years, it could completely change, especially if we found a way of harnessing dark energy. That is really the key thing. I mean, obviously, that's a big cosmological mystery right now. But if we find that we can harness that energy, warp drives could be even more science fact than science fiction. So,
but to say the words like harness dark energy, would be like saying harness dark matter, which is to say harness something that you have no idea even really what it is.
Yeah, it's
you kind of, so that's like harnessing unicorns or something. I'm not sure.
I want to point out this is coming from the guy who wanted to capture the energy of a black hole earlier this week.
Yeah.
Dream
total
big,
science.
Fraser.
Total.
Well, a frightful eclipse. Of course, that's a play on words because we're talking about one of Mars's two moons, Phobos, and Phobos was named after the god of fear in Greek mythology. Astronomy's fun because you get to learn so much about mythology while you're learning about space and the universe. Well, Phobos is interesting. Of course, Earth has its moon, and the moon is a quarter the size of Earth, so it's a good, it's a good relation there. But Mars's two moons are really, really small. They're basically asteroid sized, and I mean, whether or not they're actually captured asteroids or they came from an impact collision that happened billions of years ago on Mars, the jury's still out on that. But for the most part, they're just two little space rocks. And Phobos is actually maybe 16 miles wide across at the largest. So I've got a shot here I can show you of. Jump over here. Now you can see an animation taken by ESA's Mars Express, and that shows what's going on with Phobos. Phobos, like I said, about 16 miles wide at its largest, and it's covered in scratches, and it has has craters all over it. It's your standard little asteroid type thing. Well, it only orbits not even 6,000 miles above the surface of Mars, and it orbits very quickly just to keep that orbit. So Curiosity was able to, let me pop this, well, I'll just keep talking here. Curiosity was able to train its camera, its mass cams, on the sun, knowing that Phobos was going to cross the face of the sun. Basically, Mars had a solar eclipse. Now, it's not like the solar eclipses that we have here, where, on occasion you can have a total solar eclipse and the entire sun gets blotted out, or you get an annular eclipse and you get that really cool ring of light around the sun like we had last year. This is really more of a transit event. You end up with a little silhouette. So Curiosity was able to capture a little bit of Phobos as it crossed in front of the sun. And you can see here we have an animation. Let's see if it... Yep. There it goes. And that little shadow, that little silhouette is that moon that I just had up on the screen passing at about 5,800 miles high in front of the sun. Now, it didn't go across the sun. It kind of snuck along the side there, but that's what it caught. And, that was something that Mars Exploration Rover engineers, they knew this was going to happen. They had that ready to go. Those cameras were trained on the sun, and it was just another case of being in the right place at the right time and knowing what's going to happen. Orbital mechanics, they know where things are, and they managed to catch that. And that was on the 13th. So
that was Curiosity, right? Not the Exploration Rovers.
That was Curiosity.
Yeah.
Mars Science Laboratory.
Yeah. Which is
now okay. Correct me if I'm wrong. Isn't that one of the MER mission?
No. Spirit and Opportunity, the MER, MSL is Curiosity.
Okay.
I hate to call you out like that.
Sorry, I know, right?
For him, Jason. But no, but I mean, it's amazing that they had the time, to be able to, with all the science and all these tests they've been doing with Curiosity in the last couple of weeks, that they could actually stop. The mechanics were working out. Yeah, look up. Let's watch an eclipse happen as well. Yeah,
well, sure.
absolutely.
I mean, what they want to do is, learn more about Mars's moons. Sometimes Mars's smaller moon, Deimos, will pass in front of the sun as well, and that's a lot further away. It's a lot smaller, so that's really just more of like a little dot. But Phobos does this every now and then, and it has been caught by the Mars exploration rovers before. I believe Opportunity caught a little video of Phobos doing exactly that. Actually, even more in the center of the sun. So
yeah, no, I definitely have seen that in the past. That's amazing. Yeah.
And what's cool about it is, if Phobos really was a chunk of Mars that was thrown out into orbit at one time, orbiting for a while, they think that possibly within 11 million years or so, that orbit's gonna degrade. Phobos will start falling back down. It'll pass its Roche limit there, and the tidal forces of Mars will rip it apart. Now, whether or not it's actually going to impact the surface or turn into a ring, I'm not quite sure yet. But Phobos's days are numbered.
It'll do one, then the other. It'll turn into a ring, then impact the surface, right?
That'll be interesting.
But yeah, absolutely. When you think about it, it's actually an amazing fluke that we are able to see Phobos now. That it's really only going to last for another 10 million years or so.
Yeah, in a small period of time.
Yeah, and the chance that we're here to be able to see it is really lucky. Although who knows? Maybe Mars has had 4,000 moons over its long history, and they're constantly crashing to the surface. So, but yeah, no, quite fortunate. Very cool. Now, did you build that animation, Jason? I know you watch the raw images coming from Curiosity like a hawk.
There was an earlier animation that I built where it was more of a wide angle, but that one there was zoomed in a bit more because I think it used Curiosity's 100mm mass cam, whereas the one that I had built a few days ago used the 34mm. So it's a bit more of a wide angle.
So they saved the better pictures for themselves. Cool. All right, cool. Let's move on. So, Amy, you have been covering Neil Armstrong's funeral. So, what was the story with that?
Yeah. So, the details have kind of come out pretty slowly. NASA released a picture of the funeral on September 14th. Neil Armstrong was buried at sea. So I don't know how many people actually know this, but Neil Armstrong was actually a trained naval aviator before he left to join the NACA, which was NASA's predecessor, to be a test pilot. So it's quite fitting that he was buried at sea. And also fitting because, I mean, he was so private and so kept to himself and was very reserved. Sea burials are done on active duty ships. So family can't be there, although in this case, because Neil Armstrong, his wife, was actually there. The family typically doesn't know when sea burials are going to happen, where it's going to be, what the ship is. All the details come to the family later. The whole ceremony is just presided over by the commanding officer. So, like a lot of naval traditions, and it's an intricate, like a really nice, very, fitting send-off for somebody like Neil Armstrong. And NASA hasn't released tons of details about his service at all, but the Navy has a lot of details on its website. So I sort of pieced together what a typical Navy burial might look like. So everyone on the ship dresses in what they call the uniform of the day, which is a certain level of dress that depends on your rank and your season, and also the ceremony that is going on. So it's probably a dress whites or dress blues, depending on rank. Officers prepare the deceased for the burial. If it's a casket, a flag is draped over it with the star field resting over the left shoulder. And if the flag is displayed, the caps and sword of the deceased are not. If it is cremated remains like Armstrong's funeral, the flag is just suspended, held by 6 or 8 sailors over it as though it were a casket. They bring it to a pre-planned point on the ship called the launch point, which is also oddly fitting for Armstrong. If it's a casket, the feet are hanging over the side completely parallel, or perpendicular to the ship's deck, rather, with feet hanging over. And everybody is drawn to attention and brought to attention in formation around the launch point. The commanding officer reads a committal to the sea to sort of commit the burial, and the sailors tilt a table up and hold the flag, and the casket just slides right off into the water feet first. If it's cremated remains, they can actually be dropped from an airplane or just scattered over the side, also from the launch point, and there's no tilting. I don't think they drop the urn. I think they just scatter. So after the body has been committed to the sea, they call for parade rest, which is an odd stance of holding your hands up crossed in the middle of your back with your elbows pointed straight out. Everyone bows their heads and a prayer is read, and then they fire 3 shots, and someone plays taps. The sailors who've been holding the flag then fold it in that sort of triangular thing that we see a lot, fold it twice along its long axis and then into this triangle so that only the star field is showing. The commanding officer gets that, and that's what he sends to the family, and then dismisses everybody, and then they go back about their day. So it's a really, it's got a lot of ceremony. It depends too if the deceased was very religious. There are religious elements, and it can be done with a priest doing certain prayers. If not, then it's just the commanding officer. But it's, other than a possible priest, it's totally military. And it's of course limited to people who were, sort of worthy of this kind of ceremony. Active duty military, of course, who didn't die at sea, retired or dishonorably discharged military, civilian marine personnel, or any U.S. citizen deemed eligible by the Chief of Naval Operations for noteworthy contributions to the U.S. government. I don't really know what constitutes that, but I know Gene Kelly was buried at sea, so apparently there's all kinds of types that are able to get this this service. But there's also actually a company in New York City called Nature's Passage that does sea burials for the everyman. So they put you in a fully biodegradable shroud. It's actually really environmentally friendly, much more so than burying anything in the earth or putting a big steel box in the ocean. And I actually heard an interview with this guy a couple of years ago. It's really interesting the way that sea creatures will then use the body. It's so gruesome, but we'll use the bodies to sort of create a new habitat, and it really does sort of help keep the cycle going in the water, because that's what they used to do. I mean, way back in the day, it was just someone died on a boat, you wrapped them in some sailcloth and committed them over the side.
Now, Amy, correct me if I'm wrong, but now the urn that was used for Neil Armstrong, it looked to be, and I didn't realize this at first until someone mentioned it and sent me a link, it looked to be made of sea salt, because I see that they make urns of Himalayan sea salt that are used exactly for the purposes of burials at sea. So, when they go in, the entire urn goes in, but within, probably within a few hours to a day or so,
right,
it dissolves.
Oh, I didn't actually see that. When I was looking at the stuff that I found, but I did most of it, the research on the military site, so they don't talk about different types of urns very much.
Neil's urn was, it was kind of a pinkish, pinkish orange. It looked to be some sort of almost like a marble texture or marble pattern to it. And then somebody mentioned, what happens to that? And I said, well, I believe the whole urn goes in into the sea. And then someone else sent me a link to and I think it was Alan Boyle over at MSNBC. He sent a link to a site that sells these Himalayan sea salt urns. So after a while, the entire thing dissolves. Oh,
that's very environmentally friendly. I don't know. I haven't actually found that. In some of them say that the commanding officer will send pictures and sometimes a video of the flag and the urn back to the family with the details of when the ceremony was, where. They give coordinates so they can revisit the spot if they want to. But I don't know about the details. They've been quite mum on the details.
That's nice. I'm sort of thinking of something like out at the end of Star Trek II, right, where they had the photon torpedo and they all sort of did their ceremony and they played taps and then they shot the torpedo out into space.
First?
Feet first, yeah. So I think it was something quite similar to that.
Yeah.
Good. Well, thanks. That's a lot of detail. That was I didn't realize there was that much sort of to the ceremony and that kind of a tradition. So that was great.
And of course, every step is the certain call done in a certain order and certain ranks and certain armbands, and it's quite lovely for a funeral.
So on to Nancy now, and Nancy, you're going to talk about the fact that Curiosity has discovered pyramids on Mars.
Yeah.
No. It's going to be examining a very interesting looking rock on the surface of Mars.
Right. Well, there was another press briefing yesterday for MSL, and Curiosity has done some more driving. And by about, I think they're at Sol 44 now or so. Curiosity has driven a total of about 290 meters or 950 feet. And the big news was that, yes, they found a pyramid on Mars. They picked out their first rock to do kind of the first complex set of arm operations. And it's really kind of a cool-looking rock sitting out there on the plains of Mars. It has a pyramid shape, and that's sure to set the conspiracy theorists on a new tangent, probably. The team has named the rock after Jake Matijevic, who was a rover engineer. He was a systems engineer who worked on the Sojourner team. He actually led the surface operations for the Sojourner rover, and he also worked on the Spirit and Opportunity rovers and did some work on MSL, but unfortunately he passed away right after Curiosity landed. And so to honor him and his contributions, the team named the first rock where they're going to do the big full-up contact science on after Jake Matijevic. And I don't know if you remember, but this rock actually looks a lot like the first rock that Spirit examined back, 8 years ago, which I think was called Humphrey, if anybody can remember. MSL's John Grotzinger said yesterday that the Jake rock is about 25 centimeters tall and about 40 centimeters at the base. So
the Martians built very small pyramids.
Right. And so it's this rock just kind of sitting out there in Gale Crater, and people were wondering how it got there. It looks, the rest of the ground is just kind of a uniform kind of a soil, and then there's this rock sitting there. They think that it might be it might have come from a secondary impact ejecta, not Gale Crater itself, but another one. The rock looks like it's in pretty good shape, so they think that it's probably a harder rock than the surrounding, the regolithian area. So the great thing about the rock is that it looks kind of uniform in composition, and so what they want to do for this first full-up arm operations is do some comparisons between two of the instruments that are mounted on the arm, the alpha particle X-ray spectrometer, or APXS, and also ChemCam, which is the fun one that everybody's excited about because it uses the laser to vaporize tiny sections of the rock. And so they want to be able to do cross comparisons between the two instruments. That'll help with the final calibrations and get everything ready to go. And they expect to stay at that rock for a few days before going on to Glen Elg, which is their target to do lots more surface science. And they've got about 20 more meters to reach that, but it kind of depends how interesting the Jake rock is as to when they're going to really get there. But again, what they've been seeing so far in Gale Crater is kind of just a largely soil-covered surface with a few exposures of bedrocks. Kind of the more interesting one they encountered was the one that was right away excavated by the thrusters during landing. And they didn't say too much about the bedrock yet, but they said that they're working on their observations and hope to have a story on that next week. So look for more interesting things about bedrock. And then the other interesting thing that they're getting ready to do is getting ready to use the Chimera, which is the collection where they do the scooping and that kind of thing. And they said to get ready for that, they're going to do some air scooping, where they just kind of go through all the motions and just kind of scoop some air and go through all the motions of actually doing all the scooping and getting it into the instruments and all that. But they hope to be able to actually do that over the next 3 weeks. And that's probably about all the news from Curiosity.
That's fantastic. Thank you. Last but not least, we're going to talk to Nicole Gugliucci about the oldest, furthest, youngest, most distant galaxy ever discovered, ever?
Ever
to date?
and ever to date. Yeah, I personally cringe whenever I hear, oldest, furthest galaxy, because, in a few months we'll come up with another one.
I was hoping the dripping
the
sarcasm was coming through there, but because we've all gone through this so many times, right?
Well, yeah. It's coming through as well as it can on my slow internet connection. But so this galaxy was discovered by the Hubble Space Telescope. It's this itty bitty tiny little red dot in the image that Jason is showing us. It was discovered during a clustered lensing survey. And so in order to see these very distant galaxies, often the light has to be lensed or bent around another massive galaxy cluster that's along the line of sight to this very distant galaxy. So that's what's going on here. It was detected by Hubble Space Telescope and followed up with the Spitzer Space Telescope. So this galaxy is seen in infrared wavelengths, so wavelengths longer than the light that our eye can see, because it is so far back in the universe's history that the light has been stretched out, roughly speaking, and redshifted. So this galaxy is at a redshift or a Z of about 9.6, and so it's actually not the first time I've heard an announcement of a galaxy at such a large redshift, but I don't think the previous ones had been confirmed, and I haven't actually seen the data for this one yet. I haven't found the paper. I don't have a nature subscription at home to actually take a look at the data, and I'm sure it's being based off of a small number of photons being collected. But a galaxy that's this far back in the universe's history, so it was around in the first 500 million years of the galaxy's 13.7 billion year history. This is an early epoch that we don't know much about. We call it the epoch of reionization. And what's happening here is that the space between the galaxies is full of hydrogen gas, neutral hydrogen gas. And these new galaxies that are forming are giving off so much ultraviolet light that it is ionizing, reionizing the hydrogen gas in between the galaxies, and so that's where it gives it its name. We haven't yet detected the signal of this hydrogen gas yet, but there are a lot of different radio observatories working to be the first to do that. This is a very difficult experiment. So we don't know much about the galaxies themselves. So being able to see these galaxies, so if this is further confirmed, this would be the first confirmed galaxy during this early epoch, in this first 500 million years of the universe's existence. So yeah, it's, even though I cringe at the oldest, furthest descriptors, it is interesting that we are starting to find these galaxies that are so far off, because we don't know much about the universe's early history. We don't know quite much how these first galaxies were formed, how these first stars were formed, how these first black holes were formed. So when we actually get to see them directly or see some evidence of their existence, we're learning something completely new.
Right, there's still all these big unsolved questions, right? Which came first, the supermassive black holes at the cores of these galaxies, or
right.
did the galaxies form first and then accrete these supermassive black holes? Did the big spiral galaxies we see today, did they all come together in one big, or did they, accrete in small little pieces over time? I mean, there's tons of these questions. But
right.
This is sort of at the very, very limits of what Hubble can do, and only thanks to a massive gravitational lens.
Right.
Let's just, next up is going to be the James Webb, which should take all this to the next level. I mean,
yeah, and this is part of what James
destroyed, right?
Yeah, this is part of what James Webb Space Telescope is being designed for. It's working in longer wavelength bands, so it's focusing on the infrared, and it's doing kind of what Hubble did, exploring all these galaxies, but at a further distance than Hubble can. So it's actually going to be able to pick up galaxies like this, this first one, if it's as bright as it is, no problem, and actually be able to explore this population of galaxies and tell us what these early epochs were like. So, yay, James Webb, get finished.
Get finished, yeah. Break all these records.
Yeah.
Cool. Well, that was all the news that we had scheduled for today. I guess there's a couple of other things. I don't know if anyone's working on this as well. Endeavour is going to be making its trip to. It's in Houston right now, right? And the weather has pushed it back. Is anyone working on this story? No. Alan is, and that's why he's not able to join us this week. But yeah, from what I understand, the Endeavour is being transferred to the California Science Center in Los Angeles. And so it was supposed to be flying out today, but weather delays in Houston, so I think it's going to be going out tomorrow, and then it's going to wait on the tarmac in Los Angeles while they sort of extract it from the carrier aircraft, and then in October they're going to do this amazing journey from LAX to the California Science Center. They had to cut down 400 trees to make it fit as it moves along the highway from LAX to its final resting place. And what, of course, the really cool thing about this is they're going to be jacking it up vertically, not horizontally, and then they're going to put the solid rocket boosters, the fuel tank, and so you're going to be able to actually see the space shuttle in all of its glory in the California Science Center. So very, very exciting stuff.
And apparently the best place to view it in LA, when it flies over, apparently it's flying over on Friday, that's the schedule. Apparently the best place to observe it is going to be like the Hollywood Hills Griffith Park Observatory area. So
yeah,
that's going to be really cool.
Yeah, I mean, same thing as with all the other shuttles. The carrier aircraft is going to do this low fly right over the city, and everyone's going to get a beautiful view of the shuttle. It's be great to live in Los Angeles. Hey, wait a minute, you live in Los Angeles, Ian?
Wait a second.
Yeah, the shame, the thing is, because I was kind of expecting it to fly, I think the original plan was today. It was, yesterday, Wednesday, it was supposed to be flying over. And I've since made plans, and I'm probably going to be in San Diego, of all times. So hopefully we'll be running late and I'll be able to see it. But I'm not entirely sure of the times yet, so need to check it out. But also another horrible bit of luck, the reason why they chopped down all those trees was because it's going to be towed from the airport to the science center, and of course, that they, to actually tow it along the highways, they needed to chop down some trees. Unfortunately, I'm going to be in the UK when that happens, because otherwise I would have been down there to see the thing. But it's just awkward timing, so that kind of sucks. But we'll
Get
be
some
covering
pictures of some chopped down trees then.
Yeah.
It's okay.
It's okay. Scott's there. He'll get some pictures.
Yes.
Okay, so we've got a couple of minutes left. I actually haven't seen a lot of questions. I don't know whether we have somehow perfectly answered everyone's questions, even
No
the
questions
warp
about
drive,
the universe?
even the warp drive ones, which I find quite surprising. So, but anyway, if anyone wants to ask a question to the team here, you can ask your question on the event page where we initially sort of mentioned the Hangout. We've got our the Google Plus page on my feed where you can see all the questions that I've been posting links to all the stories. You can also ask a question over on YouTube if you have any questions, or if you're watching this somewhere else, you can post a question on Twitter with the hashtag #SpaceHangout. Now, is there anything while I'm sort of filling time while people compose a question
to my cat?
Here's Jason's cat.
He will answer all space questions. I mean, he's brilliant. He's brilliant. He's a very tiny voice.
Already reached the pet time.
I'll mention that the Astronomy Photographer of the Year competition and winners were announced last night at the Royal Observatory in Greenwich, and the pictures are absolutely awesome. We have an article on Universe Today, but you can go to the Royal Observatory website and see them as well, and they're on Flickr too. So awesome images.
Well, then I'm going to, while we're doing that, while we're waiting for some more questions to come in, I'm going to show you our cool Phases of the Moon app that we just are working on for Universe Today. We've just updated it. Now check this out. We go, whoa, look at the libration of the moon. Isn't that cool? And it actually shows you press the back button, and you can actually see the distance to the moon is actually changing in real time. I don't know if you can see that.
Cool.
Yeah. Whoop.
Nice.
You get that? Nope. Now it's got a widget. Yeah, so it's really cool, and it shows you the rise and set time in your location, and it's on. Oh, there's Nancy's version too. There you go.
I need to get that.
Yeah, it's really cool. Now that's the iOS version.
Mine is Android.
That's the Android version, which is better than the iOS version. So we actually have one on iPhone, but it's not as pretty as the Android version. We
this is
develop an
smooth
Android
as silk.
first, which is how we roll. So
this is timely because Saturday is International Observe the Moon Night, and so we'll be celebrating here on Hangouts, but also at events all over the world. Go up and look at the moon. People will be looking at the moon. There will be star parties all over the world. If you go to observethemoonnight.org or observemoonnight.org, I'm not sure. Someone needs to check that.
do search for Observe the Moon Night. Yeah, But we're going to be,
Observe the Moon Night.
and we're going to be doing this here on Google Plus. We're actually going to be hooking up a couple of telescopes on Saturday night. I think Scott's going to be doing it, and he's actually going to be out in public with his telescope broadcasting his view of the moon. So he's going to be doing outreach and all that at the same time. That's going to be really neat.
And I did a podcast today with Brian Day from NLSI. Yes.
Oh, Pamela's hosting that. Okay.
Pamela's hosting one Friday night, our time. So Saturday for
observethemoonnight.org.
There you go. Observe the moon. This is falling apart, people. So hold on, Nancy, you were mentioning something.
I did a podcast today about International Observe the Moon Night. It's on 365 Days of Astronomy, also on the NLSI podcast. It's with Brian Day, and we talked about this. So all the links are there at 365 Days of Astronomy or NLSI podcasts.
Okay, cool. And so I got one question here. This comes from Denise Yalson. So are those furthest galaxies full-blown galaxies, or are we just seeing early baby galaxies when we look so far into the past?
So this far out, this one at Z of 9.6 is probably a baby galaxy. Now, because they can't resolve it, it's just a point source on the picture, we can't really be sure. But most of these galaxies that are very far distant are baby galaxies, unformed, not big spirals. And so it's thought that, they formed as smaller galaxies and then later coalesced into bigger galaxies. What's surprising is at about a redshift of about 6 or 7, so a little bit later than this galaxy, there are some really massive galaxies with really supermassive black holes in the center. So within that first billion years, really big galaxies did form, and we don't know how. But this one's probably in the baby galaxy category.
Right. Cool. Okay. We got a question from Nick Rutledge. About Curiosity, does the rover have enough power to run the laser and all of the other equipment at the same time, or does it happen shut off equipment so the laser can charge up?
That's a good question. I think it's got enough power. Does anybody else know?
Yeah, well, actually, I've done 2 live shows with Emily Lochtewald from the Planetary Society, and that woman is a walking, talking encyclopedia of curiosity, and so we had some very related questions to that. And so I'm going to try and remember the things she taught me, which is that Curiosity is powered by an RTG, a radioactive thermal generator, which is a sort of decomposing nuclear pile of radioactive energy, and so it extracts the heat out of it and is able to use that to power itself. So it doesn't use solar panels the way that Spirit and Opportunity do. So it's actually got a lot of power. I mean, Voyager, all the other spacecraft were powered by the same kind of reactor, so it can last a long, long time. Now, the main use of this energy is actually to run heaters, because what happens is at the nighttime, the temperatures plunge on Mars, and all of its electronics would freeze up and it would die without being able to run these heaters. So at night, the rover uses this energy to keep itself alive, not die at night. And then during the daytime, when the sun's out and the temperature warms up, then it's able to move around and do science. Plus, it can see. So then it actually has an abundance of energy, but I don't think it has the energy to run, lots of experiments all at the same time. But like I've got a laser, a little portable laser that I can use. It doesn't put the same kind of power out, but it just runs on a couple of AA batteries. So, I don't know exactly sort of what its sort of power structure is and what it does, but I would assume that they focus on one, experiment at a time. So. Carolyn McCardle asks, if distant galaxies appear red, can you tell us what colors they would appear if they were close to us?
So these young galaxies are likely made up, or that the light's likely dominated from really massive stars. So whenever you have a star-forming region, the light is dominated by the biggest, most massive stars that live the shortest lifetime. So it tends to be blue, ultraviolet. Back at this early time in the universe, there were a lot less of what astronomers anachronistically call metals, so anything other than hydrogen and helium. And so you can make even bigger stars at this epoch for reasons of interstellar physics I don't quite all remember because it's been a couple years. So if you don't have these heavy elements, you can make much larger stars as the gas clouds are collapsing and cooling, and so you're going to have even more of these blue ultraviolet stars. So they're probably blue ultraviolet if you were, standing next to it, if you could stand next to a galaxy, but then it gets redshifted down to the infrared by the time it gets to us.
Right, and so the redshifting is the speed of its motion away from us thanks to the expansion of the universe.
Right.
So there you go. Okay, well, I think we're all done with the questions, so let's get with the self-promotion time. So, Amy, where can we find out more about you?
You can find my blog Vintage Space if you Google Vintage Space, which is easier than finding my website, which is amyshirateitel.com. But I'm also at Discovery News and a bunch of other places.
That's right. Dr. Ian O'Neill,
Yeah,
Dr.
you can.
Warp Driveology.
Yeah, if you want more warp drive stuff, you can find. I'm actually writing an article about warp drive and energy, basically what I discussed just now. So I'm hoping to put that out today. But you can find that on discoverynews.com, and I'm also over at astroengine.com. That's where the bulk of my writing is. And I also do an opinion piece for Al Jazeera English. So you can find me in those 3 places.
What was the last opinion piece that you did with them?
Curiosity, actually. It was an update about Curiosity dominating Mars. I'm kind of obsessed with the fact that we just landed a tank on Mars. So if you're from a Martian's point of view, we're invading Mars. So
Absolutely.
About
That's
time.
great.
Yeah.
Jason Major, at JP Major at Twitter, lightsinthedark.com. Where
And
else?
universetoday.com, of course, and where I have a lot of articles there, along with you guys, along with Fraser and Nancy, and I also help Ian out a little bit on discoverynews.com. If I find a interesting picture, I'll send it his way. And where else am I? I think that's pretty much keeping me busy these days.
I hope people are sort of getting the sense of how space journalism works here, which is that we all work for each other. Ian will lift stories off Universe Today, post them on Discovery, so will Alan. So yeah, no, we're a
little incestuous. It's okay.
Nancy Atkinson is our esteemed editor at Universe Today. What are you working on today, Nancy?
I'm going to write about do a kind of a follow-up on the Jupiter impact. I talked to a couple of astronomers, and I got some kind of interesting things about that. And like I said, I did a podcast for the NASA Lunar Science Institute today, which I do twice a month, so you can find me there too.
So are you going to be able to explain why it created such a big explosion and yet not a big splat on the surface?
Yes, I will try.
Okay, cool. And Nicole, where do we find out more about you?
So I live at noisyastronomer.com, and I spend most of my time on CosmoQuest. So I'm a postdoc working with the CosmoQuest project. So come do citizen science with us. It's super awesome.
And I hear a person can map an asteroid.
You can map asteroid Vesta. It has the most bizarre craters and surface features. Yeah, go to CosmoQuest and go to Do Science, and there's an asteroid mappers or Vesta mappers project. We have all the most high resolution images from the Dawn mission. So Dawn just left Vesta for Ceres. There's a bit of a little Twitter jealousy going on there between the asteroids. You can actually see them tweeting at each other.
That's funny.
Which has nothing to do with any of us here in this hangout. So the data from the Dawn mission at Vesta is there for you to peruse because there's a lot of data, and the scientists need help from citizen scientists to mark all the surface features and find all the boulders and find all the craters and all the weird stuff on the surface. So yeah,
So if you-
science.
So if you feel like you haven't made it your mark in science yet, by all means go to Asteroid Mappers and help find all these craters. This is brand new. These craters have never been seen before, so
Yes.
no, it's fantastic.
And we
Cool.
still
And
have
then-
images of the moon, so go play with moon mappers too, because the moon's a lot bigger, so we still have those.
Right. And more pictures, yeah. And and you can, of course you can find me at Universe Today, and I'm writing all kinds of stuff here on Google+. And if you do want a copy of our cool app, you can go to Universe Today, and there's a little moon phase picture on the side, and you can click the links to either the Android or the iPhone. So,
Do that right
so
now.
that would be great. Help us out. Cool. All right. Yeah, we'll work on the iPad version next. All right.
Oh, there's no iPad version? Okay,
No,
fine.
not
I'll do it
yet.
on my phone.
There you go. All right. Well, thanks everybody, and we'll see you all next week if we don't see you earlier for our virtual star party and for the International Observe the Moon Night. So thanks everybody for joining us, and thanks everybody for watching, and we will see you all next week.